As I promised in the previous video of this series about PDC Bit nomenclatures, I'll make this volume about the additional features. Before going in depth through these additional features, it's important to mention what are the essential features of any PDC. Any PDC bit has the following essential features. A body of the bit which may be made of matrix alloy or steel. Number two, a number of blades. Number three, a number which indicate what are the cutter sizes on each blade. Number four, each blade should have one row of cutters. Number five, it's standard to have just one nozzle per blade. Number six, 2 to 3 inches non-step passive gauge pad. Number 7, irregular following the API pin-up connection. With the previous points about the essential features of the PDC bits, the eye will easily notice another row of cutters at the shoulder area of each blade. It's very useful to have such a feature, especially while drilling the abrasive formations, because the backup row or the second row reinforce the action of the first row and extends the life of the bit. These features is considered an essential feature by Smith and made a separate product line which they call the Shark product line. The other companies still consider it an additional feature and give it different abbreviations. Varel, for example, give it P from power cutters. Halliburton give it D from dowel cutters, and Baker make it extra rows and give it the letter X. The presence of the 360-degree revolving cutters at the nose and shoulder area is another feature. It is specific for Smith bits. The rotation of the cutters make it stay sharper for a longer time and extend the bit life. Another feature which is specific for Smith bits is the conical element, diamond conical element. This feature may be just one conical element at the middle of the cone area or a multiple of conical elements at the backup row area. This is known as the Z feature. Each one Z when one conical element at the middle of the cone area, or double Z when multiple of these elements are found at the backup row area. The conical shape of this element fills the formation more efficient and increase the bit stability and reduce vibration. The oval cutter, rather than circular ones, are a new feature for some Varel pits. This feature is useful in direction work by the conventional motor, where less weight on bit is required to proper engage with the formation, and this produce more uniform torque profile and more stable tool face. In some bits, we may find some extra fixed ports. For Smith bits, they call it Q feature. The purpose of these ports is to provide additional area for more flow, for better cutter cleanings, and ROB when the nozzle compromise bit design. When the bit has a number of nozzle more the number of blades, they call this feature higher nozzle than standard. Smith give it each symbol. This feature allow utilizing the maximum flow without increasing standby pressure. On the other hand, when the bit has a number of nozzles less than the blades, they call it fewer nozzles than standard and give it N symbol. This, of course, will increase the hydraulic horsepower of the bit without the risk of being plugged if a smaller nozzles are utilized. The low exposure feature, which include cutter packing raising to minimize the depth of cut, is very useful when drilling is going to carried out through heterogeneous formation. The feature minimizes the cutter breakage and extends bit life. Impregnating the cutter packing could be considered as a secondary feature to the previous feature, which include impregnating the cutter packing with diamond to limit the PDC cutter wear and increase the bit life. These circular patterns at the backup row position may be of carbide or thermally stabilized polycrystalline diamond are known as chuck studs. They are useful in controlling the torsion vibration because when drilling condition cause vibration, these chuck studs make contact with the formation to help restore the bit's normal smooth cutting action. Smoothing the cutting action increases the cutter life and overall bit performance. When these patterns are found in the shoulder area, they call it the anti-whirl feature. Smith give it V letter. It's important in controlling the lateral movement of the bit. The gauge pad may be covered by TSP inserts to increase the gauge pad life and keep the hole engaged. When the application requires a full tilting of the bit, like the point the bit rotor steerable system, they stepping the gauge pad into 2 or 3 steps. This feature is given the G1 by Varil and the E by Halibert. The gauge pad is called active gauge pad when it has cutters on its side. These cutters make it more aggressive and help in the side track operation, but on the other hand, it generates high reactive torque at the rock pit interface. When the gauge pad is longer than the standard, 4 or 5 or 6 inches, is called extended gauge pad. Smith give it letter E in the additional feature part. It enhances the bit stability and improve bore hole quality. It's very useful if no aggressive direction control is needed. On the other hand, when the gauge pad is shorter than standard, 1.5 or 1 inches, for example, it's called short gauge. It is useful when aggressive direction work or maneuvering by the motor is to be carried out. The back reaming cutters, P by Smith and U by Verrill, are those cutters at the upside of the gauge pad. It improves back ream and minimizes the possibility of bit sticking. When that cutter is in the downhole direction of the gauge pad, they call it drop-in cutters and is given letter D by Verrill. This helps to keep the hole engaged while drilling or downhole reaming. This was the last part about the PDC nomenclature, and it was about the additional features in the PDC. It's important to know that the same feature may be given a different letter to characterize it by the different service companies. So it is very important to have a record for each service company to fully understand what is meant by each feature and to avoid misunderstanding the indication of that letter.